Hi, everyone. This is the very brief set of words entitled, and now a word from our sponsor. I am George Saab. I'm in charge of the Java team at Oracle and also the chair of the OpenJDK governing board. It is my extreme pleasure to welcome you all to Oracle Santa Clara campus once again, and for us to hold this fantastic event. This is something that over the years has been great, and so we're really happy to do it again. And we hope you'll all enjoy it. So just very briefly, it's 2.5 days of technical presentations. This is a very technical conference, aside from what I'm saying right now. But it is a chance to connect with the experts at Oracle on the JVM, and also kind of from around the industry, because many of you who are coming to visit who don't yet work at Oracle are also fantastic resources. This is really your chance to talk with people, to give feedback, to talk about ideas of things you'd like to see in Java. And really, just to give you an idea here, the things that we talked about at this conference 4 years ago are now coming to fruition, right? So the result of this conference is immense. The opportunity to talk about things that then become a part of the JVM are fantastic, and I think really just unparalleled. For the conference as a whole, as you can see some of the stats here, we have people from quite a number of countries, from a lot of different companies represented. We have people who are recognized Java champions, and also representing a lot of the user groups around the world. So this is fantastic. It's a great sort of microcosm of the Java ecosystem, and also people who are interested in the JVM as the target platform, the target runtime for other languages. And that's certainly something that we've seen over the years, is that while we focus a lot on the JVM for Java, it also is an opportunity to talk about the JVM as a target for other languages. I wanted to mention just briefly something that we did a few years ago that we're also now seeing has had a tremendous result. So many of you may be familiar with the change that we made to the release cadence for the JDK. This is something that we really sort of started thinking about after the experience that we had at Oracle of delivering JDK 7 and 8. We sort of thought, maybe there's something we could do to improve the latency with which we're able to deliver new features and new versions of both Java and the JVM. And so there were a couple of things that we did there. I just wanted to mention them because I think this is something we're really starting to see become important. The number one thing was we looked at the Java platform in terms of things that we could do in order to make faster delivery possible, so things like modularization. But we also looked at the way that we were delivering the JVM. And one of the conclusions that we came to was we had been trying to make the latest JVM version work with multiple JDK versions, and that really kind of held us back in a lot of ways. So we decided to make a conscious break with that, and to instead work on always doing our development and innovation on the tip version, and then understanding that a lot of people in the world, we thought, wanted the latest things in the JVM, but it turned out once we made this change that many of them really didn't. Like, we had the sort of conceit to think that the latest stuff we're doing, everyone in the world wants that immediately. But it turns out that there are a lot of people who want that, but there are a lot of people who just want stability. And so basically what we found was that many of our customers thanked us for not foisting the latest, newest version of the JVM and Java on them, and instead giving them something that was stable and letting them choose whether they wanted to go to the newest, latest, coolest. Now, luckily, a lot of people want to go to the newest, latest, coolest. And so what we've seen over time is a gradual pickup and momentum around the tip versions of Java, and around the tip versions of the JVM, of course. And this has really meant two things. One is we've been able to deliver new innovation in the JVM more quickly to market, because we're not worrying about supporting as many versions. Basically, that I think also has meant that over time, we're getting to a point where people are no longer comparing the latest version of other language runtimes out there with Java of 8 years ago. Because that's kind of an unfair comparison, right? But we were forcing it upon people. So anyway, this is a conscious change we made we've been really happy with it. We'd love to have your feedback. We actually think that there's kind of an opportunity for more of the ecosystem to move to this kind of development. And that's something I'd love to hear people's thoughts about over the next few days. So if you see me in the hallway track, just pull me aside and tell me you want to talk about it. Whatever your opinion is. Doesn't have to be the same as mine. So anyway, I did think I'd just mention that because I think it's something that really has been an enabler for us. And so that's one of the reasons we're here, is not just to think about specific features, but also how we're bringing those to market. Anyway, with that said, I know people want to hear some more technical content, so I'm going to hand it off to Mark. Thank you again, and welcome.
Welcome. This is the JVM Language Summit, as George said, 2023. It's been a while since we last left our story, as the narration goes. Well, why are we here? This is from the JVM Lang Summit webpage. We're here to collaborate. We're here to share experiences. We're here to talk about the JVM, programming languages for the JVM, and we welcome and we learn from the experiences of people who work on things other than the JVM, or people who work on languages other than Java. Of course, what we're primarily interested in is Java as a language and a platform, while languages on top of the JVM are extremely important. So despite having been declared dead on numerous occasions, Java is still, and I always enjoy saying this, one of the most popular programming platforms in the world. Here's the latest iteration of the RedMonk programming language rankings. Ranking programming languages and platforms is a difficult art. There are lots of indices out there that try to do this. Some are more realistic than others. I happen to think this is probably about the best one I've ever seen. Is it hard science? No, but it's fairly indicative. So on the x-axis, you have the popularity rank of a language on GitHub by number of projects. On the y-axis, you have the popularity rank on Stack Overflow. Stack Overflow might be dying, I'm not sure. So, but anyway, this is still useful since this is based on historical data. So the RedMonk folks collect this. They used to do it, I think, every quarter. Now they're doing it every 6 months. And they correlate all this data. And for a long, long time, Java has been way up there in the top, next to Python and PHP and some language named JavaScript. It's vaguely related to Java, I think. Anyway, Java's been there consistently for a long, long time. Why has Java been so extraordinarily successful for so many years? Well, one part of the answer is our relentless focus on two big goals. One of those goals is developer productivity. Java is about helping developers build and maintain large and reliable programs. The other big goal is program performance, and that's performance measured in many different ways. Performance measured as time in startup, warm-up, latency, or throughput. Performance measured as space in terms of static or dynamic footprint. We pursue these two goals in the face of constantly evolving things, constantly evolving programming paradigms, such as mixed functional and object-oriented programming, evolving application areas, such as big data and machine learning, evolving deployment styles, the cloud. I mean, Java wasn't, the cloud didn't exist when Java was invented yet. Here we are today, and it's very popular in the cloud. And of course, evolving hardware. The hardware that we have today is vastly different than the hardware we had 28 years ago, with terabyte memories and deeper memory hierarchies and vector and SIMD instruction sets and deeper and more numerous processor pipelines. Now, as important as the goals we choose are the means by which we choose to pursue them. And this is another one of Java's big strengths, is that we have always taken the time to think about the big picture and the long term, try to peer ahead into the future to see what developers will need, not just now or 2 years from now, but 5 years from now, or even 10 years from now. To put it another way, we don't act only as developers, that is, people who create things. We also try to be responsible stewards. We try to oversee and protect something considered worth caring for and preserving, and that is the Java platform. We try to preserve the past while evolving for the future. Our work, as I and others have often said before, is guided by two core values: readability and compatibility. Readability is essential to maintainability. If you can't read the code that you wrote a year ago or that a colleague wrote 10 years ago, then you can't maintain your code. Compatibility has many different axes. There's the technical sense of compatibility, which we all know and love from the JLS, the source, binary, and behavioral, the usual triad. There's the concept of migration compatibility, the ability to gradually introduce features without requiring mass adoption of those features across all existing code bases. And finally, there's a thing that I like to call intellectual compatibility, the fact that millions of developers around the world have invested the time and effort to learn this platform. They're deeply invested in this. As we move Java forward, we want new features to build on existing knowledge. We don't want to ask people to have to throw away existing knowledge in order to adopt new features. Preserving these values while moving the platform forward is much, much harder than it looks. Anyway, when we last met here, way back in 2019, that was 4 years ago, we had just shipped JDK 11 and JDK 12. So the previous JVM LS was right here 4 years ago. After that, we shipped JDK 13, and then we were rudely interrupted by the pandemic. But during the pandemic, life went on, right? We're all sitting on Zoom, we're still hacking away, and we just kept turning the crank and shipping those 6-month releases, and they just kept coming out. Finally, the pandemic ended, at least according to some people, World Health Organization, this is their definition, it ended this past May, and here we are. And we are on the cusp of shipping JDK 21 in September. So it didn't stop us, maybe it slowed us down. Maybe in some ways it actually sped us up because a bunch of us spent less time on airplanes going to conferences. But anyway. So 4 years ago, we were talking about these 4 major projects, among other things. We're talking about a lot of other stuff too. These 4 projects, I mean, George talked about bearing fruit. We were talking about these projects 4 years ago. They have borne fruit. They've made a lot of progress since then, so let's take a look. Amber, all about right-sizing language ceremony. Since we last met, Amber has delivered a slew of small features. What have we got? We've got pattern matching for instance. We've got records. We've got sealed classes. We've got switch expressions. We've got text blocks. We've got pattern matching for switch and record patterns. All of this stuff. And we have more on the way. In preview, we have string templates, unnamed classes and instance main methods, and unnamed patterns and variables. As you can see, Amber has been a project that's particularly well suited to the 6-month cadence. It's been very amenable to being sliced up into small deliverables, each of which builds on the other, but there's a whole cohesive story here. Everything fits together. Okay, Loom. 4 years ago, we were talking about Loom, and Loom was all about continuations and fibers. Fibers? What was that? Wasn't that some obscure feature in like Windows 95 that looked like threads, but wasn't really? Well, no. So Loom went through a serious exploration of how should we add these lightweight, thready things to the platform. And for a while, it was important to explore, well, should they be fibers, a concept distinct from threads? And eventually we learned that, well, no, it actually made sense to make them be another kind of thread, because that would be the easiest thing to adopt. It would make for the smoothest migration from existing code that uses Java lang thread to code that can, with a small amount of change, use virtual threads. So virtual threads as a feature were first delivered in 19 in preview and finalized in 21. Along with virtual threads, we have scoped values, which are still in preview in 21, and structured concurrency, also in preview in 21. So between these 3 things, I think Java is going to revolutionize how large concurrent systems are built. All right, moving on. Panama, as John originally conceived it, is about repairing the isthmus in the VM. There are two aspects of this. One is very nearly finished. Maurizio has done a heroic job of wrangling the foreign function and memory API. Unlike Amber, this was not something that could be divvied up. It's a fairly big deliverable in one piece. It's been in preview for a while now, and it's in preview almost certainly for the last time in 21. We'll finalize after that. I'm really looking forward to using it. The other part of Panama is kind of a historical accident. In retrospect, this probably should have been a separate project, but here it is the vector API, which Paul and others have been working on for a while. That's coming along. It's usable, but it's kind of doomed to be in incubation for quite some time, because the ultimate version of this, and this is an example of looking to the long term, the ultimate version of the vector API will benefit immensely from Valhalla. So we will keep turning the crank on, turning the incubator crank on the vector API. It's usable, it's there. There are even people I hear who use it in production, which is cool. But it will change and adapt as Valhalla comes into play. Speaking of Valhalla, Valhalla is about unifying primitives and classes. Originally, Valhalla had two goals. One was to enable increased flatness and density of data structures to improve locality, which would improve performance. And the other was to unify the Java type system, to heal the historical rift between primitives and classes that was there from the very beginning. Now, when Java was created in 1995, that was a practical necessity. Technology was not available. Techniques were not available to unify those in a sensible way on the hardware available at the time. So it's always been a sort of distortion in the platform that we've learned to live with. In many ways, when you program with Java, after a while you just don't see it anymore. But then you run into some weird problem and realize, oh well, gee, well if there just weren't this rift between primitives and regular classes, my life could be easier. So Valhalla's been cranking along for a long time. It's gone down a number of paths, some of them fairly deeply. There have been a number of changes over time. Periodically, Brian or John will tell me, I think we're almost done. And then 6 months later, one of them says, well, now I think we're almost done. and I've learned to be patient. The really interesting thing about Valhalla is it recently took an unexpected turn, and as we were working on it, people realized, well, the best way to solve some of these really thorny design problems having to do with bucket 2 and bucket 3, and well, do you want primitive classes or value classes or primitive value classes and all this other stuff, is to actually take on a third goal, and that's nullity control, or emotional types, or nullness annotations, or whatever you want to call them. A feature that many people have been begging to be added to Java for many years. Other languages on top of the JVM, like Kotlin, have had this for a while, and it has obvious value. After all, Tony Hoare was right when he referred to null as his billion-dollar mistake. So, somewhat surprisingly, Valhalla is now aiming to solve that problem. And will not only be a performance play in terms of locality and a productivity play in terms of unifying the type system, but also a productivity play in terms of doing nullity control. So Valhalla hasn't delivered much yet. There have been a couple of preparatory JEPs for hidden classes and warnings for value-based classes to help people get prepared for eventual potential migration of existing classes to value-based classes. There are 4 JEPs waiting in the wings. Dan and others have been furiously working on these for value objects, user-defined primitives, classes for the basic primitives, and enhanced generics. So a lot of exciting stuff has been done in the last 4 years. This week, we will talk about some of this work. We won't be talking about Amber, at least not in formal sessions. Certainly in the hallway track, that's possible. We will be talking about Loom, Panama, and Valhalla. We will be talking about some new things as well. For example, Paul will be talking about code reflection, the work he's been prototyping to symbolically describe and reason about Java code. He still has to come up with a cool name for this one, but I'm sure he will in due course. Eric will be talking about generational ZGC, less memory, less overhead, and fewer allocation stalls for most kinds of workloads. Roman will talk about Lilliput, which is all about shrinking object headers in order to reduce footprint, thereby improve locality as well. And then finally, John and I will be talking about Leiden, which is about improving startup warm-up and footprint by selectively shifting and constraining computation. So I don't know about you, but I've really been looking forward to this week. Have fun, enjoy the talks, and enjoy the week. Thank you very much.